Welcome back, guys. Now here now we'll discuss about a nodal analysis only. Node analysis. So continuation of node analysis. So I'm here with a concept called supernode. Okay. So what does the supernode means? Node analysis. For example, I'm taking this small circuit. Let us say that is a T circuit, pi circuit or a T circuit. It's okay. Okay. So what is the node here is, this is a node for us, and this is a ground, and this is a principal node, and we're having a principal node, and this is simple node. Is leave that. So for if you have two principal nodes, I'm taking this as a ground, and this is a node. Okay. This is a normal node analysis. Well, coming to super node. I'm having the same circuit. Let us take this is a circuit, and I'm taking a source here and some load here. So here what is the nodes we are having? This is one super principal node. This is Pn1 I'm taking, and this is also one principal node. This is Pn2, and this is one other principal node I'm taking. This is a ground. So at node this I kept V1 and it is V2, and this is ground. If you observe carefully, if you observe carefully at this resistance, I kept one source here, that is voltage source. Okay, so you will feel the difficulty to do the KCL at this node. For example, if you want to do KCL at this node, we assume what currents are leaving, right? But if you want to find the current here is, you cannot find. If you want to find current at this node means, we'll do what? V2 by this resistance. Let us say the resistance is R1, R2 and R3. So V2 by R2 plus V2 by R3. So what about this current? You don't have any current here. So you'll this point the normal analysis will get failed. Okay, you cannot proceed by normal node analysis. Here in this type of circuits, you need to observe that so this is node 1 V1, let us to V2. The super node means when one voltage source connected by two nodes, then it is super node. Okay, that means this voltage source is connected by two nodes. Then this overall V1 voltage source V2 comes as one node. So that is called a super node. Okay. So when so in this if you have any in middle there is a resistance, then it is not a super node. Should not have any resistance. Should not have any resistance between that nodes. If you have that resistance means, here there is a provision to find current. You can find current, right? So for example, the same circuit I am taking, plus minus, say I am taking the same circuit. But as R said that between any voltage source, in between two nodes, if you have a voltage source, it will become super node. But not that. If you have a resistance means, what happens here? If you want to find a node KCL at this point, you can find current here. So let us say I1, I2, I3 in this I am taking. So KCL is proving here I3 equal to 0. What is I1 is V2. So current is flowing like this. V2 plus this voltage source value, let us take 10 volts. V2 plus 10 minus V1 by this resistance. Let us take this R1, R2, R3. that resistance plus V2 by R2 plus V2 by R3. So here KCL is proving at this node, because you are having resistance in between these two nodes, but in this case you don't have any resistance, there is no provision to find current. Therefore, if you're not having any provision to find current, then when two nodes are connected by the voltage source, we call it as a super node, that is node. Okay, so keeping, so what is, how we do with this? So in this place the actual node analysis is, let us take this is 20 volts and this is 10 volts and this is 2 ohms, 3 ohms, 4 ohms. Okay, now we'll start at this node. We have the habit of starting at this node. Directly we are having a voltage source here, therefore V1 equal to 10 volts. I'm taking this is ground. This is equation 1. Okay, now what about so V1, you got one equation V1. So keeping this as a super node, what we have here is V1 minus V2 equal to 10 volts. This is equation 2. So you have equation 1 and equation 2, substitute these two, you will get V2. So you get V1 and V2 directly. Okay, now we'll solve one in different form. For example, let us take this circuit. So I am taking this type circuit. I am having adding N1 resistance here. Let us 2 ohms, 3 ohms, 4 ohm, 5 ohm. So this is 10 volts I am taking. This is 20 volts. So at this, so this is one principal node. I am taking V1 and this is also principal node and this is grounded. Now, so at node 1 you need to find KCL. But if you see you have provision to find current here. So I want to do KCL. You have provision to find current here, current here, current here. No, there is no provision to find current here. Therefore, what you do is, you'll take, so now by observing this, V1 and V2 is straight away write V1 and V2 are super node, form super node. Okay, that means this is entire thing as one node. One node. Now KCL at super node. So what is the KCL at super node means? At this point, at this end point, these two currents are leaving. So what you do is V1 this current value V1 minus 10 by 2 plus V1 by 3. So at this left side our currents are dead. Now coming to right side, so the currents are leaving. So this current means plus, we'll continue this equation. At left part is over. Left part of one side of other node is completed. That is, we did currents of this and this. Now right part of this currents means V2 by 4 plus V2 by 5 equal to 0. This is a super node equation. So at this we will considering this as a one super node, and now at this two junctions, we left side the currents are leaving. So we gave those two equations, and from the right side these two equations. So one super node is completed. Okay, now inbuilt super node. Now inbuilt super node. Sorry guys, inbuilt super nodes, what you have is by super node, at this node by V1 and V2 we'll get V1 minus V2 equal to 20 volts. This is equation 2. Okay, so we'll take, I'm assuming current from here to here. So V1, if I take two nodes, say let us say, so any node source here, so plus minus terminal I'm taking, and minus plus terminal I'm taking, and this is V1 and V2. If you are taking current from V1 to V2, then the equation is V1 other terminal, other voltage terminal having minus, so minus V2 equal to this voltage source 20. So now again V1 and V2 are having, to take from here the value will be V1 plus V2 equal to 20. So take assuming currents is from here to here, and other terminal opposite terminal have plus, therefore we take plus here. Okay, this is about Prince super node. So so I'm continuing the super node thing here with the aid of the super node equation what I explained before. I'm going to explain one sum for you. So I'm taking the complicated circuit since it is having many meshes and many nodes, and so many people will get confused to solve these type of questions. So in journey of solving this, you may arise many different tasks. So I'll take time, just listen carefully. If you observe this thing, if you know how to do all these things, what are the things occurred, I'll ping that and give you the complete analysis. So basing in this analysis, you can solve any circuit. Now the question is, find power developed or deliver and power dissipation. So he is asking, in this circuit having what are the sources we are having? This is one independent sources and two dependent sources. So many people will think that this is independent sources and this is dependent sources. So what many people will think that all these three sources will develop power. So, okay, but that is wrong conception. So in many cases, always the dependent source will not act as a source element. It may act as a load, that is, it attracts load. So this may attract load, or this may attract load, or this may generate, or this may generate. So why this happens is, so in some cases we don't know why this VA, voltage across this inductor, will act as. So basing upon the this voltage, so this current source is decided by the voltage across 1 ohm, and this voltage source is dependent by the current through 40 ohm. So in some cases this act as a load, and some cases it act as a load, or some cases it act as a source, or this can be source. So let us find what are the elements acting as a source, and what are the elements acting as a load, and what is the element acting, how the power is dissipated. So the question is, find power delivered and power dissipated by node analysis. So many people find difficulty in doing node analysis. So it's not much difficult what you are thinking. Here how many node mesh analysis you have? 1, 2, 3, 4, 5 meshes you have. And what are the how many nodes you have? This is node V1, and this is node V2, this is node V3, this is node V4. We are having 4 nodes here. So keeping node analysis, we'll find the power generated by every element. So apply node at node 1, that is apply KCL at node 1. So for node analysis we use KCL. So at this point we assume that currents are leaving. Okay, so currents are leaving. If this current will be drawn by V1 by 20, this current is given by V1 minus V2 by 2, and this is, what about this? So doing this current you find difficult, but you observe the voltage source and you have. So therefore the KCL at node 1 is not possible. Now the node 1 and 4 form supernode. Okay, so now what do you do? These two nodes you observe now. These two nodes and this voltage source form a one supernode, that is node. So at this junction you will find currents leaving from V1, and again currents leaving from V4, that is this current, 3 currents are leaving from V4 and 2 currents are leaving from V4. Therefore totally 4 elements you will get in this case supernode equation. That is supernode equation at node 1 is given by V1 by 20 ohm plus V1 minus V2 by 2 ohm. This thing is completed, and again at this node, let you get V4 minus V3 by 4 ohm plus V4 by 80 ohm, and the current leaving is plus 3.125 VA equal to 0. Okay, all of you got this equation. After getting equation, if you observe that this entire thing, you should be in V1, V2, V3 form. But if you in this case, VA is there, which is not solved. So in this circuit, this current source, which is a voltage dependent current source, this current source depending on the voltage across 1 ohm. So how we'll write VA is, so this is, as this is load, okay, we assume current is leaving from here. That means VA can be written as V2 minus V3 by 1 ohm. So VA, sorry. VA is a voltage across, so voltage across this branch, that is VA, this from if current, assume current is, this is the load, if you assume current is leaving from this node, so VA can be written as V2 minus V3, that is V2 minus terminal of V3. Substitute VA here. After substitution, directly I am writing one equation, it's a V1, V2, V3 form. So we make V1 common, we will having 1 by 20 plus 1 by 2 minus plus V2 of minus 1 by 2 minus 1 by 2. So you will substitute VA here, you will be getting a value of 3 plus 1, 2, 5 plus V3 into minus 1 by 4 minus 3.125 plus V4 into 1 by 80 plus 1 by 4. So further solving, you will be getting a V1 of 0.55 plus V2 in 2.625 plus V3 into minus 3.375 plus V4 into 0.2625. This is equal to, so this is the equation 1. After getting equation 1, so we completed node 1 and node 4. From node analysis again, from the inbuilt, so V1, V4 currents are leaving, but we have to find the inbuilt supernode by inbuilt supernode. So having a V1, V2, we can write V1, V2 equal to what? V1 minus V4. The voltage, branch voltage across the 35.35 IB is V2 minus V4 equal to 35 IB. That is the voltage which is within two nodes. Now again V1, V4 you got, IB is got. IB is an again obstacle. How we will find IB means, IB is a current flowing through the 40 ohms, that is this is the branch voltage is V3 by branch voltage V3 by 40 ohms. Substitute this here. So again you will get the value of V1 minus 0.875 V3 minus V4 equal to 0. Let us say this is equation 2. So you get two equations, and you need to get two equations because you have to form 4 nodes. Therefore at node 2 you have directly V2 equal to 20 volts. Okay, you need not to worry now. And again at node 3 by KCL, so assume that currents are leaving. So I will get V3 minus V2 by 1 ohm plus V3 by 40 plus V3 minus V4 by 4 ohm equal to 0. The further calculation, you will be getting the value of minus V2 plus 1.275 V3 minus V4 into 0.25 equal to 0. So these are the 4 equations you got. Because in calculator you will have 3 equations concept, but here you got 4 equations. But you may have the lead that V2 is directly having a 2 volts. Therefore substitute equation 3. So choose that where the equations have V2, that is compute equation 3 in equation 1 and equation 4. Now from 1, so from 1, substituting this equation, you will have a value of 0.55 plus V3 into minus 3.375 plus V4 into 0.2625. So substitute this value here, you take that side, you will getting minus 52.5. This is equation, let us say 5. And again, from equation 4, you will having a value V2, substitute in the value, will get to that side, you will getting 1.275 V3 minus V4 into 0.25 equal to the substitute minus 20, that cuts to that side, that is 20, so equation 6. Now to get some equations, from equations 2, 5 and 6 in the calculator, if you calculate, you will be getting the value of V1 equal to like say minus 20.25 volts, and V2 equal to, already have the 20 volts, and V3 equal to 10 volts, and V4 equal to minus 29 volts. So you got completely these 4 equations. So after observing the equation, just find after seeing the circuit, just find where is the super node. So V1, V4 form the super node. From this we got the super node equation. After getting the super node equation, just find whether this, from this super node we will have another equation, that is inbuilt equation, which is V1 minus V4 equal to 2, and substitute that obstacle by having the voltage V3 by 40, and after that you find from node 2, and again all these things. Okay, if you get 4 equations, you will interchange the equation and forms to transfer into 3 equations, solve that 3 equations with the calculator, you will find these values. Okay, fine, everything's good. So up to now things are good, very good. Now what we have to do is, we have to find the power developed by the sources. Now this thing is a discussion thing, you need to understand. Now I want to introduce one small topic, that is how to find whether the system is source element or the load element. For example, I think this box is a source. Okay, so I'm having a inside or outside the terminals like this. Okay, so if I'm assuming that the current is delivered, let us say current I, and the voltage is V. If I assume that current is delivered and voltage is V, so the value which is current is I is positive, this is also positive, then the power delivered by this is positive. That means the power which is observed is positive, so the total power, so if you get the positive, means it is delivering the power. For example, if it is considered as the source, in this case, if I take this terminal like this only, but a current I is, we obtained is negative, and the voltage is positive, then the power P equal to VI will be negative. Therefore, I consider this is as a source. Initially, I thought it is a source, and I thought I find current I, which is leaving from the positive terminal, but I am getting the negative, and this is the positive. The overall power is negative. So the power is negative, I choose it is as a source, therefore it is said to be load at this case. Again, another case, I take this positive negative terminal, and again the current is leaving, and the voltage I have. If the current is say positive and the voltage is negative obtained, and the power will be Vi equal to negative, that is negative, then again in this case also you act as a load. Another case, if a power I am taking as PVI, if I take current as a negative value and the voltage also a negative value, then the power equal to Vi. So in this case, the negative into negative will get a positive value. Therefore, in this case, it is source. So all this analysis is done keeping that this is a source, this is a source, that is current is leaving. Whenever the positive, from the positive element current is leaving, we say that is a source. Okay. Now, well, if we consider a thing which is load, that means from this terminal current is entering. Okay. If the voltage which is positive and the current is also positive, then the power equal to will be positive. That means this will act as a load. Okay, things are normal here. So load means from the positive terminal current will enter. That means it is positive, this is positive, and we got positive value. The source means current is leaving. This is positive, the total power is positive, the current is delivering. It's okay, fine. Now what about this value if I am having a voltage V and the current is obtained as a negative and the voltage is positive, and the power delivered will be equal to positive. Therefore, in this case, it acts as a source. Okay, we are considering this as a load out our assumption, but current obtained as negative, the voltage as positive, therefore it is acting as a source. Okay, now if again another case, current entering, if I get this is a positive and the voltage is negative, then the VI equal will negative. If this is negative, we are observing this as a load, so it is opposite of that, this is a source. As simple as that. Again positive, I am taking this as a negative, I will be a negative value and V is also negative, therefore we are considering this as a load, but we obtained negative and the power will be equal to VI, so the total will be a positive value, therefore it is acts as a load. Okay, so compare these things. So why I said all these things means, for this circuit you will imply all those things now. Okay, so I am again redrawing the circuit. Let us say this is the value of this is current I is leaving from here, that is 40 volts, this is 4 ohms, 80 ohm, 1 ohm, 2 ohm, 20 ohm, so same circuit I am drawing for you. 3.125 VA, and again this is the value of I took this is as V1, V2, V3, and this is entire thing is V4. This is 20 volts, this is a 35 IB. Okay, now we got V1 a value of V1 has a value of minus 20.25 volts, V2 equal to 20 volts, and V3 equal to 10 volts, V4 equal to minus 29 volts. Now we will find the power delivered by this source, that is 20 volts. So power delivered by 20 volts can be represented by P 20 volts. To find the power delivered by that source, so power means what? We should have voltage into current. But we are having voltage, but we need current. How to find current flowing? That is power. So I am considering this is a source. Therefore, I need to find current I. Let me keep this is I here. So to find current I, it is flowing from this node to, and it is diverting from this node to this node. Therefore, if you find currents, let us say this is I1 and is I2 and I3. So I1 will be equal to currents entering into it is equal to currents leaving. Therefore I2 plus I3. So how we will find I2? From this node to this node, the current is I2. So by node branch voltage by resistance, that is V2 minus V1 by 2 ohm plus V2 minus V3 by 1 ohm. Substitute the values of V1, V2, V3 here. You will be getting I1 value equal to, I already calculated these things. So okay, I got 30.2. So I got I1, I am 20. So that the voltage, the power delivered by this 20 volts is the voltage which is 20 into the current I1. So substitute this I1 to 20 into 30.125. So you obtain the value of P20 as 602.5 volts. Okay. Now our main thing starts here only, the discussion part. So I want to find current voltage divided by 35 point IB. So I take this 35 point IB. Since we are saying this as a dependent source, we assume this as a source here. That means the current will be leaved from positive to negative. Okay, that means the voltage value, let us say this is current I4. Therefore power delivered by this 35 point IB, which is equal to the voltage 35 IB into the current I4. Okay, now we'll find IB. So what is the IB means? IB we have so IB equal to what? V3 by 40. So already we have V3 as 10 by 40. So we have this is as 1 by 4. So 35 IB is 1 by 4. Now we need to find I4. How we will find I4 is, so I4 is a current leaving from this side. Okay. Now we will find I4 here. How we will find I4? I4 means we are having a V3 here. Okay. So let us take at this node voltage, the current. So by KCL, this is a one node. So by KCL, how we will represent, this is let us say I5 and this is I6. So I4 can be represented as so I4 can be equal to, so current entering should be equal to current leaving. So your current, every current is leaving, therefore I4 plus I6 plus I5 plus 3.125 VA equal to 0. Okay, so I'm assuming that current from, if I think that this is a source, that means you should have I4 value. So to get I4 value, again I'm choosing currents are leaving here. So I4 means minus of I6 minus of IY minus 3.125 VA. So I6, how will get I6 means V4 by 80 minus I5 means V4 by 4 ohm minus 3.125. The value of VA is, what is the value of VA? VA, this is VA. So again VA is, so we will write VA. So we are having VA equal to what? 1 into current flowing from there, from V1 to V3, that is V2 minus V3. Substitute here, you will get V2 minus V3. So after calculating, you will having a value of I4 equal to a value of minus 21.13 amps. So I got I4 as negative. Okay, so this is minus 21.13 amps. Therefore I get out P35IB a value of minus 184.88 volts. So we are choosing this as a load, this as a source, that is we are considering as a current is leaving from the positive terminal, but I got negative. So if I think this is a source, if I get current I as a negative, that is I4 as a negative, but this is a voltage value, this is positive, therefore overall thing is we got is negative, therefore this is acting as a load here. So the PI4 is a load, a value of load value 184 point, so the load value of 184.88 volts. Okay, this is the whole thing I want to explain. For this to justify this thing, I explained that before, and now we will find the power delivered by this thing. So this is P 3.125 VA. Okay, now again I am assuming that this as a source. Now in this case, if I assume this as a source, that is current is leaving from should be leave, let us say this is minus positive terminal I am taking, but if I consider this as a source, okay, the current is leaving. If I consider this as a source, that means say for example, this is the current I am taking, this is the voltage I am taking. Now current is leaving like this, that is current is going if I downwards, therefore then negative terminal should be there and positive terminal should be here, then only this so positive and negative, so in this case only this will act as a source, because current is, in this case current is going upward and positive and negative terminal, current sheet is going downward and this is positive and negative terminal. So now in this case we'll find how we'll acting as. Okay, so power delivered by this is current value 3.125 VA, this is the current value, and the voltage value is how take voltage, so V4 is a voltage with respect to ground, which is actually a positive value. But here in this case, if you take this is a positive value, now we have negative terminal, but we have to take from this keeping as a source, we take this as a minus V4. Okay, now how will get the V4 value? So getting the V4 value, how will get V4? So already we are having a V4 value, already find that. So 3.125, what is the value VA you got? VA is V2 minus V3 and minus of V4. So 3.125 V2 is 20 minus 10, and again V4 minus V4 is minus of minus 29. So you obtained a value of 906.25. So I did calculation based upon assuming this is a source. So from the source means a positive terminal current is leaving. So I kept, actually the voltage V4 is in general assumed as positive and negative, but we are assuming positive and negative, therefore voltage across this branch I kept minus value. So I totally obtained the positive value. Therefore this is as a source here, and this case, so now by concluding this we finally say that P20 volts is a source, actually source, and P 3.125 VA is a source, but P35 IB is a load value. Okay, now we'll find power delivered, power dissipated, or power dissipated by different elements, that is power dissipated by P2 ohm, that is this value P2 ohm. What is that value? So the voltage across this branch is V2 minus V1 by whole square by 2 ohm. So you will get in the value of 810.03 volts, and power dissipated by P20 ohm. which is equal to V1 square by 20. So you obtain the value of 20.5, and the power delivered by P1 ohm, which is V2 minus V3 whole square by 1 ohm. So you obtain the value of 100 volts, and the power dissipated by P40 ohm, which is equal to V3 square by 40. So you get 2.5 volts, and the power delivered by P80 ohm, which is equal to V4 square by 80. You will obtain the value of P80 ohm, which you obtain the value of 10.51 volts. So this completed, 20 ohm is completed, 2 ohms is completed, 1 ohm is completed, 40 completed, and now again P4 ohm. The P4 ohm is a value of V4 minus V3 whole square by 4 ohm. You obtain a value of 380.25. Okay. So the total powers dissipated by the different resistance we got. Now our job is to find the total power delivered. So this is the delivering sources are, these two are delivering sources, and this voltage source, this is dependent source, and all these things are power dissipated elements. So the voltage source power delivered is P20 volts plus P 3.125 VA, which is equal to, so what is the power, 602.5 watts plus 906.2 watt. You will obtain a value of you obtain the value of 0.2.5 plus 906.25. So 602.5 plus 906.25, value of 1508.75 watt, and the power dissipated. So what are the power dissipating elements? That is the dependent source, that is P35 IB plus P20 plus P2 ohm plus P1 ohm plus P40 ohm plus P4 ohm plus P80 ohm. So the P35 ohm you got as only 184.88 watt plus P20 ohm as a 20.50 plus P2 ohm as a value of 810.03 plus P1 ohm is 100 plus P40 ohm is 2.5 plus 380.25 plus P80 is 10.51 volt. Okay, so adding all these elements, you will be obtaining a value of 810.03 plus 100 plus 2.5 plus 380.25 plus 10.51. So the value which is nearly equal to 508.67. So by this we say that the power delivered is almost equal to power dissipated. Nowhere these two will get equal when theoretically. Practically, when a consignment will get power dissipation. Okay, this is the approach. So whatever the circuit, just find the power delivered elements. You straight away don't consign that all the depending source will generate power, but there will be some cases. In this case, this is acting as a load. In this case, it is source, and the rest of this thing follows. In the next class, I'll be with you with other circuit called with the mesh analysis, the complicated circuit, same way, and we'll do the mesh super mesh equation also. Thank you guys. Share with your friends and give your feedback to me. Thank you.